Hi, I'm Nicole. Welcome to my math channel. I will share with you the method to solve Singapore Secondary 1 maths topic in my channel. For information, the difficulty of each topic will be separated into basic, intermediate, and advanced level. Today, I'm going to show the basic level of the topic 1, factors and multiples. Let's start. Okay, this is the book that I'm using for the channel. And please look at the question number 1. In the first question, they are asking you about the factors of the following number. So in each of these basic level question, I will show maybe 1 or 2 examples so that you can understand the concept. So what is the factors? Factor is the number that those numbers can be divided by. For example, like 18. 18 can be divided by 2, 3, and maybe 6. So 2, 3, 6 here is the factors. If I want to save the time to find the factors, I will suggest you start from 1. So for example, 1 times 18, 2 can times 9, I will get 18. 3 times 6, 4 cannot, 5 cannot, 6 times 3. Now you see, the number repeat, right? If it repeats, that means that is all the factors of the numbers. So we can list down like that. 1, 2, 3, and then 6, 9, and 18. So this is the way that we can find all the factors easily and will not miss the number. For example, look at B, 20. So 20, I can get 1 times 20, 2 times 10, 3 cannot, 4 times 5, and then 5 times 4. You see now 5 repeat, 4 also repeat. This means our factor just 1, 2, 4, 5, 10, and 20. And let's look at the next one, multiples. Question 2, multiples. What is multiples? Multiples is like the timetable that we memorize. For example, question number 1. Multiples of 4. They want you to list down first 5 multiples. So for example, 4. The next one will be 8, 1, 4, 4, 2, 4, 8, 3, 4, 12, and then 4, 4, 16, and then 5, 4, 20. Then we can stop here because they just ask you to list down the first 5 multiples. Then we don't care the rest. Okay. Next term that you need to understand is index notation. Index notation is we can group the number with the same base. For example, in question 3a, all of them are base 2. So they are same, then we count. The 2 appear how many times? 1, 2, 3, 4, 5. So I can say 2 power of 5. So this is index notation. And if you look at question 3b, I have 2 times of 2 and then times 4 times of 3. 2 and 3 are different base, so we will have to separate them. 2 times 3. And then count. 2 I have 2 times. So I write 2 here. And 3 I have 4 times. So the answer will be 2 power of 2 times the 3 power of 4. That's it. And now we will go to the question number 4. Let me make it smaller. Okay. They ask you to find the prime factorization of the following number and then write your answer in the index notation. So the best way is, I need to know this 96 can be divided by what number? And then I must use the prime number. Prime number is a number that only can be divided by 1 and itself. So for example, like 2. 2 can be divided by 2. And then 2 can also be divided by 1. So these two fulfill the requirement, so the 2 is the prime number. The special case is 1, it is not a prime number because 1 can divided by 1, and then 1 when divided by itself also 1. So both are same, so cannot. So basically the prime number all should be odd number except 2. Okay, now we can try question number 4a. Okay, 96 I will try divide by 2. If 96 divided by 2, I will have 48. Then 48 divided by 2, 24. And then divided by 2 again, I will get 12. And if I continue, divided by 2, I will have 6. Divided by 2, then I will have 3. And the last one, I will have, divided by 3, I will have 1. So you need to divide it until 1. Then I can say 96 is 2 power of 4. 1, 2, 3, 4. Oh, sorry, it is 5. And then times 1, 3 here. That's it. Okay, now we look at the question number 5. This one also prime factorization. So they ask you to make this into prime number. So you have to think how I can get 4. If I want to split it to the prime number, can I say 4 is come from 2 times 2? And this 4 also come from 2 times 2. Then you see, I can group them all together. I will have 2 power of 4. And for question 5, maybe I will explain one more example. 6 times 6 times 6. 6 is come from 2 times 3. Here also 2 times 3. The last 6 also 2 times 3. So if I write it in index notation form, I will have 3 times of 2 times 3 times of 3. That's it. Okay, now we will come to the main part of all these factors and multiples. We will find highest common factor. So highest common factor is, if they give you 2 numbers, you need to find out the common factor that, the highest number. So let me show you the slow method. So for example, 9. I want to find the factor. I use the first method that I taught you just now. So 1 times 9, I will have 9. And then 3 times 3. But you see the 3 repeat, right? So that means here it will be all the factors. So I can say for 9, the factor is 1, 3, and 9. And if I continue and find 36, 1 times 36, 2 times 18 is 36. And then 3 times 12 is 36. And what else? Maybe can try 4. 4 times 9. And then 5 cannot. 6 times 6. Then you see 6 repeat. That means we will have to stop here. So the factor of 36 will be all these. Then let me list them down. So 36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36. And if I want to find the highest common factor is the factors that belong to both of them together. So, and then I want the highest one. So they have the same factor 3, 9, and 1. 9 will be the highest common factor. So the answer is 9. But if I want to save the times, if I list down like this, it's quite time consuming. So I strongly suggest we use this method. Okay, right like that, 9 and then 36. Then we will try and divide both of them together. So highest common factor, you need to divide the 2 numbers together. until you cannot divide them together anymore. So for example, I will start from 9, number 3. So 9 divided by 3, 3. And then 36 divided by 3, 12. Okay. Then you look at the number. I left 3 and 12 now. This means now both of them still can be divided by 3. 1, 3, 3. And then 12 divided by 3 is 4. So this one is the highest common factor. So the answer I can write like that. 3 times 3. So 9. And if you continue until you divide both of them until 1. So now this one no more, and then I have 4. If I want to continue, 4 divided by 4 is 1. Then all these will be the lowest common multiples, LCM. So it will be 3 times 3 times 4. So the lowest common multiples will be 36. Okay, let me show you one more example with the LCM question. Okay, let's look at 7a. 4 and 10. Both of them can be divided by 2. 2 to 4, 5 to 10. And then, okay, for LCM, you need to find until 1. So, divided by 2 again. 2, 2, this one 1. And then 5 cannot, so just leave it like that. Then I continue with 5. So, 5 divided by 5, 1. So, the LCM will be 2 times 2 times 5, which is 20. But if you don't want to use this method, we can try using the slow method, which is list them all together. Okay. For example, 4. What is the multiples? So first one is 1, 4, 4, 2, 4, 8, 3, 4, 12, and then 4, 4, 16, 20, and 24, and so on. Then 10. 1, 10, 10. 2, 10, 20. Okay, I think I will stop here because you see the common multiples come out already, which is the 20. And LCM means the lowest. So L means lowest. That means the smallest number, the first number. Then the answer is 20. Okay, now we move to the next question. If they ask you about the HCF and LCM for each pair of the number, and ask you to write in index notation, then it's very good because this one will save the time. Let's look at question 1. 2, 3, and then 3, 5, and then the other number is 2 times 3 power 4. Okay, so if now I want to find the HCF, I want to see both of them, the maximum, if I want to divide them by 2. I have 2 power of 2 here and 2 power of 3 here. So the maximum of 2 I can divide will be 2 power of 2. If this one I cancel 2 power of 2, I will left 2 power of 1, and then 3 I cannot do anything, and then this one no more because cancel already. This I left 3 power of 4. And now I want to try with base 3. The maximum 3 I have is 4. So I divided by 4. So 2 cannot do anything. Then the 3 power of 5, I've left 1. You can write the 1 here, or you no need to write it also can. You can just write 3, because 3 power 1 also means 3. And then here will be 1. So then they cannot divide it together already. So that means this one will be your HCF. So I can write down HCF is equal to 2 power of 2 times 3 power of 4. That's it. Because they want the answer in index notation, you can just leave it like this. And if I want to continue and find the LCM, I need to divide both until 1. So this one no more. Then I left a 3 here. Then I continue with 3. Yes, that's it. So I can write all of them times together. 2 power of 2 and 2 power of 1. Together I will have 2 power of 3. And then 3 I will have power 5 because here I have 4 and here I have 1, so 3 power 5. That's it. Okay, now move to the next one. They ask about the positive square root of the number. Okay, what is square root? Actually, square root is the reverse of the square number. Square number is the same number times together. I will get 1. For example, like 1 times 1 equal to 1, or 2 times 2 equal to 4. This we call square number. It is the product of the same number. So they ask you to find the positive square root. Square root is the reverse. So that means if I say 2 times 2 is equal to 4, and if I want to say what is the square root, what is the answer for the square root of 4? Square root means what is the number that can produce the square number. So 4 come from the 2 times 2, so answer will be 2. That's it. Then you look at question 9a. 64. Square root of 64 will be 8 because 8 times 8 will be 64. So the same concept also works for the cube root of the number. Cube number means the same number times itself 3 times. So for example, like 2 times 2 times 2, it will be equal to 8. So the symbol is like this, cube root. If let's say I want you to find the cube root of 8, means you need to write 2. Okay, now look at the question 10a, 27. Cube root of 27. Then you maybe can try, maybe what number times together, 3 times, you will get 27. You can try 3 times 3, 9. 9 times 3, 27. So I can say the cube root of 27 is 3. Okay, now let's look at the question 11. Find the prime factorization of 162. So, okay, you can use this method. 162. If divided by 2, you will have 81. 81, maybe we can, because this one is not even number anymore, maybe we can try 3. So 81 divided by 3, 27. Then from just now, I know 27 is come from 3 times 3 times 3, right? So that means I will have 3 times of 3 here. So I can say 162 actually is equivalent to 2 times the 3 power of 4. And then we can try and find 288. If even number sure can be divided by 2, 144. And if divided by 2, 72. If divided by 2 again, 36. Okay, so I can say that 288 is come from 1, 2, 3, 4, 5. 5 times of 2 times together and then times 3 power of 2. Okay, then we can go to the part B. Let me erase this first. Okay, if I want to find the part B, they say find the prime factorization of the product of this 162 and 288. And from just now, I know 162 is equivalent to this, and 288 is equivalent to this. Okay, then we can group all of them together, right? I will have 6 times of 2, 6 times of 4. That's it. So this is the answer for B. Okay, now I want to tell you the important fact for the square root. It's perfect square and a perfect cube. If it is a perfect square, that means the number must be appear in even number time. So the 2 power of 6. You look here, it is even number, right? 6. The 3 power of 3 also even number 6. If I want to make it perfect square, so can I do something like that? It is square number, right? So or I can change another way. Can I say 2 power of 6 is come from 2 group of this, and then 2 group of this. And you see, if I make 2 of them together, like a partner, like this, I will have 2 cubed times 3 power of 3. This one will be the same concept like I told you just now, like 2 times 2, I will get 4. It is square number. If it repeat like this, the same number. You see, now I make them to 2 group, and these 2 group will be same also, right? So it is square number. And if I want to show about the cube number, that means I need to split the number to 3 group. So if I want to do that, I see this is 6. So if I want to make it 3 group, maybe I need to split it into 2 power of 2. You can use the power 6 divided by 2. So I divided by 3, so I will have 2, 2, 2. And then same also for the 3 power of 6 here. So I divide it like this. And then I make them one group. This one group. This one group. Then this will be the last group. Oh, sorry. Three power of 2. Okay, so you can see there are 3 similar group, right? So I can say this is a perfect cube number. And then that's it for my sharing today. And in the next video, I will show you how to do level 2 question. And it will be a bit difficult, so please stay tuned. Thanks.